Hello dear students, so from today we are going to start the chapter number first of class 10th mathematics, and the name of the chapter is real numbers. So as I have written here the real numbers, something might be striking in your mind that could there be some imaginary numbers also. So yes, there are imaginary numbers which you would be reading when you will go in the 11th class ahead. Okay, so there you would be reading about the imaginary numbers also, but right now we have to study the real numbers. So let's go deep into the real numbers. So if you see, the real numbers can be divided into two parts. So first is rational numbers and second are the irrational numbers. So rational numbers and irrational numbers combining together to form the real numbers. Rational and irrational, these are both the numbers which are combining together to form the real numbers. Now if you if you see about the rational numbers, you must have read about the rational numbers in the previous classes. Okay, so let me define the rational numbers again. Numbers that can be written in the form of p by q are known as the rational numbers. Means you can write them in the form of p by q, but remember these p and q are both are integers, and q should not be equals to 0 here. Okay, and at the same time, numbers that cannot be written in the form of p by q are called as irrational numbers. Are you getting this? Very good. Now see, if we talk about the decimal expansion of the rational numbers, because the rational numbers can be written in the form of p by q. Now if you are just dividing this p by q, you would be getting some answer. You would be getting the answer might be in the decimal form. Okay, so let's say suppose I am writing a number here that is 30 by 8. Okay, so let's divide this 30 by 8. So you would be getting 8 3 times 24, then 7 8 6, sorry, 8 7 ja 56, then 8 5 ja 40. You would be getting here 3.75. Now it ends here. So this type of decimal expansion would be called as the terminating decimal expansion. This is terminating decimal expansion. Okay, so you would see the decimal expansion of the rational number is terminating here. Okay, now suppose if I write one more rational number that is like let's say it is 2 by 3. Now if you divide this 2 by 3, you would get 0.666666. Now you can see here 6, this 6 is repeating here. Okay, so this type of decimal expansion is called as the non-terminating. It is non-terminating but repeating also, because that 6, because the digit 6 is repeating again and again. Yes or not? Yes. So this type of decimal expansion would be called as the non-terminating repeating decimal expansion. So we call it as non-terminating repeating decimal expansion. So you can see from here the rational numbers have the decimal expansion as terminating, as well as the decimal expansion can be non-terminating and repeating also. Okay, if this is so, then you would call such numbers as the rational numbers. Okay, this you have to remember. The rational numbers always have, either they have terminating decimal expansion or they have non-terminating repeating decimal expansion. Are you getting this? Very good. So rational numbers have terminating and can be non-terminating repeating decimal expansion. Now if we talk about the decimal expansion of irrational numbers, so their decimal expansion would be non-terminating and non-repeating decimal expansion. Okay, non-terminating, non-repeating decimal expansion. So this is the decimal expansion of irrational numbers. So here we have the example here, pi. The value of pi you might be knowing 3.1415, etc. So this is the value of pi, because it is not repeating. You would get here dot dot dot, and none of the digits are repeating here. Okay, so this is an example of non-terminating and non-repeating decimal expansion. Non-terminating, non-repeating. It is neither it is terminating nor it is repeating. Okay, like suppose you have the example here, root 3. So value of root 3 is how much? 1.75, etc. So this is the value of under root 3. So here also it is not repeating. Okay, at the same time you have the value of under root 2 also, 1.414, etc. something. So this is the value of under root 4. So you can see here these are the examples of irrational numbers, because their decimal expansion is non-terminating, non-repeating. Okay, if the decimal expansion is non-terminating, non-repeating, then such numbers are known as irrational numbers. If the decimal expansion is either terminating or non-terminating repeating, we would call them as the rational numbers. Okay, and both together they are called real numbers. Are you getting this? Hope you are getting now. Okay, so all the numbers which are coming in the under root 1 form, okay, like under root 3, under root 5, under root 2, under root 7, all these numbers would be called as the irrational numbers. Getting this? Very good. Now again we can divide these rational numbers into different parts. Like we can like all types of numbers, like natural numbers, we have even numbers, we have whole numbers, we have prime numbers, we have composite numbers, we have even numbers, we have odd numbers. So all these numbers are called rational numbers. Okay, are you getting? So means here, and all integers can be written in the form of p by q. Any integer you take, integer means positive, negative and zero numbers. Okay, so all integers can be written in the form of p by q, hence all integers are rational numbers. Let's one more thing I am writing here, all integers are rational numbers. 0 is also a rational number, because 0 you can write 0 as 0 by 1. So 0 is also an integer, na? So you can 0 is also an integer. So you can write 0 as 0 by 1 in the form of p by q. I have written this. Okay, so 0 is also a rational number, means all integers are rational numbers. So now we can divide the rational numbers into different parts. Okay, first you note it down. Now let's go deep into the rational numbers. So see, we have different types. These are all the types of rational numbers. So we can divide the rational numbers again in different groups. So first one is the natural numbers. Natural numbers are denoted by n. Okay, denoted by the letter n. So natural numbers, all the counting one numbers are, you suppose say 1, 2, 3, 4, etc, etc, etc. So these all are the natural numbers. Okay, at the same time whole numbers are starting from 0 now. Starting from 0, then all the natural numbers like 1, 2, 3, 4, 5, blah blah. So all these numbers are known as the whole numbers. So whole numbers are starting from 0. Remember this, and natural numbers are starting from 1. Now what are the integers? Integers represented by I, as well as we are representing it by the letter Z. So integers means the positive and the negative numbers. Like suppose I am writing 0, then more than 0, 1, 2, 3, 4, blah blah. So all these are natural whole numbers. 0, 1, 2, 3, 4. Now I'm writing the numbers in negative one also. Less than 0 is what? -1, then -2, then -3, then -4, etc, etc. So all these numbers would be called as the integers. So integers are positive, negative, including the 0. So all these numbers are known as the integers. Are you getting? Now what are the prime numbers? Prime numbers means those numbers which have only two factors, means the number and 1 itself. Okay, suppose if I just ask you what are the factors of 3, so you would call what the factors of 3 are, means factors of 3 means which numbers are dividing 3. So 3 divisible by 1 and 3 only. So only these two are the factors of 3. Okay, any number which is having only two factors, that is the number itself and 1. The number itself and 1. If these two factors are there, so such numbers would be called as the prime number. So prime numbers are having only two factors, means 1 and the number itself. Like suppose if I say 5, so 5 is also a prime number, because 5 is also having the two factors, 1 and 5 itself. Okay, now if I ask you 1 is a prime number, no, 1 is not a prime number, because 1 is not having two factors. 1 is having only one factor, that is 1. Okay, so 1 is not a prime number. 1 is not a prime number. So any number that is having two factors, let's say, so starting from now 2, because 2 is having two factors. The factors of 2 are what? 1 and 2, because 2 is divisible by 1 also as well as by 2 also. So 2 would be called as a prime number. And now you have the next example, that is 3. 3 is also prime number. 5 is also prime number. 6 cannot be, because factors of 6 are 6 is divisible by 1 also, 2 also, 3 also, 6 also. So 6 is having more than two factors. So 6 is not a prime number. The number which are having more than two factors would be called as the composite number. Remember this now. 6 is not a prime number, because 6 is having more than two factors here. We need only two factors for the prime number. So the number which are having two factors would be called the prime number, and the number which are having more than two factors would be called as the composite number. Remember this also. Okay, so 6 is not a prime number, 6 is a composite number. Okay, so you would not write 6 here, right? I would write here 7, then I have the next digit 8. So let me just tell me, 8 is a prime number or not? If I ask you the factors of 8, factors of 8 are 1 divisible by 1, divisible by 2, divisible by 4, divisible by 8. So it cannot be a prime number because it is having more than two factors. So 8 is a composite number. So 8 is not a prime number. You have to write on here prime number. So 2, 3, 5, 7. Then you have the next one, that is 11. Then the next is 13. Then the next is 17. So etc, etc. So all these are the prime numbers. So prime numbers are those numbers which have only two factors. Means 1 and the number itself. What are the composite numbers? Composite numbers are the numbers which are having more than two factors. More than two factors. So starting from 4. 4 is having how many factors? 4 is divisible by 1 also, divisible by 2 also, divisible by 4 also. So 4 is having more than two factors here. 3 factors are there. So 4 is a composite number. So the numbers which are having more than two factors would be called as the composite number. Okay. So first one is 4. Then you have the next example, that is 6. Next is 8. Next is 9. Next is 10. Then 12. Then you have 14. Then you have 15, etc. So all these numbers would be called as the composite numbers. Okay. Now even numbers are what numbers are even numbers? Even numbers are the numbers which are divisible by 2. The numbers which are divisible by 2 would be called as the even number. Okay. So first one would be 2, then 2 to the 4, then 6, then 8, then 10, then 12, then 14, so etc. So all these numbers would be called as the even number. Why? Because all these numbers are divisible by 2. So more numbers are there. Okay. So even numbers are the numbers which are divisible by 2. What are the odd numbers then? Numbers which are not divisible by 2 would be called as the odd numbers. So starting from, tell me, 1, very good, then 3, then 5, then 7. So all these numbers, etc, etc. So these are the numbers which are not divisible by 2. So the number which are not divisible by 2 would be called as the odd number. So this is how we have divided the rational number into different groups. Okay. Now in the next video we will be discussing about the Euclid's division lemma. Okay. We would start the chapter in detail now. Okay. Till then, stay tuned and keep watching. Thank you. Have a good day.